Alright, Assalamu alaikum guys. Today we're going to be doing exercise 901, inverse operations. Let me just double check it's 901, I kind of forgot what it is. Yeah, 901. And it's pretty straightforward exercise. It's your introduction into equations. I just thought I'd start it from here. Now it's nice and easy. Basically we're going to be doing what's called arrow diagrams. And the first question says complete the following arrow diagrams by writing the correct operation above each arrow. So basically, what's the operation to take it from here to here? All right, and as you can see, the difference between the two is that there's a +6 here when there was no +6 here before. Okay, so the operation that we introduced is +6, and that's it. That's all of question 1. Look at the next example. We're moving from m to m minus 5. As you can see, m exists in both, and -5 is the new introduction. So above the arrow, you'll put -5. And then let's move on to this harder one here. As you can see, we have x, and it becomes x plus 1. So that means we've added 1, because that's the new introduction here. And then finally, with the next question, with the next part here, you can see that the original x plus 1 has now been divided by 2. All right, remember a fraction like this means divided. So we're going to put divided by 2. It's always going to be plus minus times divide. So that's just a little bit of a heads up. All right, in this final question here, we go from a t to a t minus 7. You can see the -7 has been introduced. So we're going to -7. And then finally, again, we have another division by 10. So you just divide by 10. And that's all there is to it for question 1. Let's move on to question 2. Question 2 requires you to draw those diagrams that we just witnessed above. So start from somewhere and then create the result. And we generally start with the letter or the pronumeral. So we're going to start with n. So we have n. And then we're going to move across to the next thing. We're going to create 5n. All right, 5n is the new thing to be created. And we did that by multiplying by 5. So make sure you're writing in your arrows as well. And then finally, 5n plus 6. And the final operation there is adding 6. That's how you're going to do question 2. So generally, we start with the letter, n again. Okay. And then the next thing, when you're doing this, you should start with the brackets. Whenever you get brackets, start with the brackets. So the next thing we're going to do is n plus 2. And we can see we added 2. And then the final step, we multiply both of these by 5. Hence why we are finishing off with 5n plus 2. And that there will be times 5 operation. Just like that. All right, over here, let's start off with the letter A. Or we can even start with the 7. It's whatever you prefer. But I think the best thing to start with is... actually, it says from each pronumeral, so we're going to start with the letter. So let's start with A. All right, now the first thing that happened to the A, it became negative. So it's been multiplied by -1. And then the next one, we can see 7 has been added. That's how we get 7, take away A. That means 7 has been added. And then finally, we divide by 2. And that's the final step. There we go. All right, question 3, a bit more of the same. Write the operations that must be performed to produce x, produce the following expressions. All right, we start with the letter. Then you're going to move to, in this case, I think because there's no brackets, we're going to multiply by 3 first. So it becomes x, then 3x, and then 5. So really the operations here are times 3, and then plus 5 here. So over here, we start with x again. Next step, we're going to divide by 5, so we can get x over 5. And then we're going to add 10 to get x over 5 plus 10. All right. Well, I forgot to put questions in here. Give me a second. So here we're just going to complete some arrow diagrams. Start with the easiest one. I'll put in one more hard one. Or harder, I'm not going to say they're hard. We'll say they're harder. All right, so starting here, A, you can see they've told us -2, so we're going to end up with A -2. Look here, 6 plus 70, we're going to -6. That means the 6 here is gone. So then we're left with 70. And then look here, we're going to divide by 7. So that 7 there will disappear, and we're going to be left with T. That's how you're going to complete question 4. Just follow the instructions as they tell you. All right. Over here, complete these arrow diagrams showing how to get back to the polynomial. So this is reverse operations. We're going to start from somewhere and we're going to reduce it down to m. And it's quite straightforward. You won't have any issues with it. First thing you do is just look at whatever letter is missing from, whatever term is missing from here to here. That's what you're going to apply the reverse operation to, or the inverse operation as the heading of this exercise is. So right now there's a +1. To get rid of +1, we -1. And now you can see we don't have a +1 anymore. Over here, to get rid of the 2m and make it just m, we will divide by 2. That's how you get rid of the 2 here. 2 divided by 2 will disappear. And then that's it. You're left with the m value. All right, on to the next one. As you can see, we have a -2 in this one. We have no -2 here. That means that they've added 2 to get rid of the -2. Okay, and then in the last 2 boxes, we have x over 5 and just x. How do they get rid of this 5? Well, right now this 5 is dividing, so it's divide 5 here. To get rid of divide by 5, we multiply by 5. So you're starting to see what this topic's all about. It's all about applying the reverse. -2 plus 2. Divided by 5 times 5. +1 minus 1. Times 2 divided by 2. So it's all inverse operations. All right, let's see how you go with this one. From here to here, the 8 is missing. And that's a positive 8. So to get rid of that, we -8. And then here, we have -2p, the result. And over here, we have p. How do we go from -2p to p? We divide by -2. That will get rid of this part here. And that's that. So that's how you're going to do question 5. Question 6. What operations must be performed on these expressions to backtrack to a? So you're going to do something similar. 2a plus 1. We're going to start with this. The next one will be 2a, meaning I got rid of the 1. How did I get rid of the 1? I minus 1. Let me just put some boxes so you can see the operations clearly. And then finally, we're going to go from 2a to a. How do we go from 2a to a? Well, that's 2 times a. We're just going to divide by 2 this time. All right, over here, we have 2a minus 11. The first step we're going to do is get rid of that 2. So we're going to be left with a minus 11. Now, what happened there? Right now, this 2 is multiplying to everything there. So we're actually going to start off by dividing by 2. And then finally, we are left with a. We have minus 11 here. So to get rid of the minus 11, we add 11. And that's it. That's how we get to a. All right, and then finally this one here. We're going to try and go back to the letter. So the letter here is x. I want to make it so we only have to deal with x. So first step we're going to do is get rid of the 2. And we do that by multiplying by 2. Why, you say? Well, the 2 right now is dividing. So to get rid of it, we multiply. So that's multiply by 2. Then over here, we're going to get rid of the 7. Okay, it's a positive 7. To get rid of that 7, we minus 7. And then finally, to get rid of the 3, we divide by 3. As that 3 there is multiplying to the x, so we do the opposite. Divide by 3. Pretty straightforward. Next one will work very similar. Let me start from here. So here, we're going to end up at 2v plus 1. How did that happen? We divided by -7. Then we're going to end up at 2v. How do we get that? We're going to minus the 1. And then we're going to divide by 2 to get v. And that's it. Alright, that's the whole exercise. If you need to backtrack and have a look at everything, feel free to backtrack and pause the video. Look over it as many times as you can until you understand what's going on. Otherwise, have a good day, guys.